My name is Waseem Abbas, and I'm an assistant professor in the Systems Engineering Department. I have recently joined University of Texas at Dallas in fall of 2021. My background is in network control systems, which primarily deals with the control design and analysis of networks, which consist of a large number of decision-making components interacting with each other and sharing information with each other to perform some complicated tasks, such as in sensor systems, multi-robot systems, infrastructure networks, including power grids and transportation systems. In modern society, networks are all around us. They come in all different scales and sizes, ranging from networks consisting of only few components to the ones where millions of nodes are interacting with each other. And as a result, in this network size has emerged as a very powerful conceptual paradigm in science and engineering. In any network dynamical system, there are two fundamental aspects. First is the dynamical aspect, which describes how the network is evolving over time. And second is the structural aspect, which describes how different components and different agents within the network are interacting with each other and coordinating with each other. A central theme here is that network structure, which is created as a result of this coordination between various network components, can deeply influence the dynamical behavior exhibited at the system level. And we can leverage this structural information to actually control this network and design novel strategies to fundamentally control and effectively control these large networks. So by appropriately orchestrating the interconnection between these network components and information flow between different agents, we can design novel strategies for control. For instance, we can make a large network of very simple and cheap robots, which are very limited in terms of their computational and communication capabilities. We can make them perform some very complicated tasks, such as autonomous monitoring and surveillance of a very large region. So I studied this fundamental interconnection between network structure and the dynamical behavior of the system using tools from control theory and graph theory. And this information allows us to design novel control strategies to most effectively control the networks and maximally utilize the available resources within the systems. And the applications of this work are in various domains, including multi-robot systems, distributed computational frameworks, infrastructure systems such as power systems, etc. Another related problem, which I'm very actively working on right now, is the network robustness and resilience. So the information flow between various components within the network is great on one hand, as it allows enhanced capabilities, enhanced control and monitoring. But at the same time, it could also be of concern because a failure of one component might lead to the propagation of false information throughout the network, and which could ultimately cause the overall system to fail. So we want our system to be resilient against these faults and failures. Even worse, in some cases, a malicious intruder can hack into the system by taking control of one or multiple components and can cause severe disruptions and can severely affect the normal operations of the system. So the goal is to make these networks more resilient to strategic attacks as well as against these faults and failures. So I am working on this understanding this issue of network resilience fundamentally, primarily from the network structure viewpoint. Some of the problems I really am interested and I'm working on is that how can we design coordination between various network components so that in the case of failures or attacks, the network continues to perform in a normal manner. Secondly, what are the fundamental limits of network resilience and how can we design novel strategies to push those limits? And what are the network properties which, if induced within the system, will make them more resilient? These problems have become increasingly important in the modern day society because data analysis is has become an important tool, and a lot of data is being collected from various access points in these networks, not just for monitoring purposes, but also for the control purposes. So we don't want the false or corrupted data to be available to us. So my goal is to understand this issue of network resilience and propose novel solutions that are applicable to a broader class of practical systems. And for this, I have been using tools from control theory, graph theory, and computational geometry. I believe that the interdisciplinary nature of these problems provides us an opportunity to work on these problems together, collaborate collaborate with people with different expertise and complement each other's strength to work on these important societal problems of our time, and then hopefully make a positive impact on this society. And I'm very excited and look forward to pursuing this research mission. Thank you.